Stare at the group. And we're live. Okay. Hi, everybody. Welcome to the July 2023 New York JavaSIG meeting. First of all, thank you very much to Cockroach Labs for hosting the meeting. So thank you. Thank you very much. And thanks to Olivier and Orkes for the pizza. Thank you. So before I turn everything over to Olivier, just some quick housekeeping things and some announcements. Again, thanks to Cockroach Labs, to Adrian, thank you very much, and to Larry. So thank you very much to the Garden State Jug for inviting me to speak a few weeks ago. My updated ChatGPT for Java developers in VisRec. I hope to update that. The next thing is building a customized chatbot using only Java with ChatGPT. So that'll be the next thing. This is our last meeting before September, so this is our break. So yay, we have a break. There's no meetings in August, yay. But in September, we have 2 meetings. So we have one on the September 13th. This is, of course, Java 21 is going to be announced, mid-September. And we have some very special Java speakers. And we're meeting at Bank of New York Mellon, courtesy of Chandra over there. Thank you, Chandra, and Bank of New York. And the second meeting is at the end of September, the 28th of September. Steve Poole from the UK, he's going to talk to us and say, how does Maven actually work? So that should be a really interesting talk. So don't forget to hang out because we have some raffles. We have, I think we have 3 licenses, right, Gene? 3 IntelliJ licenses to raffle off. So hang out until the end. And without further ado, here's Olivier.
Thank you, Frank. And thank you for having me today. I'm really happy to be here. What we're going to talk today is kind of use case about constructing a subscription application, like pretty regular thing that you have to do in that kind of applications, and how actually complicated it is when it comes to do it as a distributed applications. So I put in place a little agenda. We're going to go and discuss a little bit about the challenge of building distributed applications and understand what are the hurdles, the challenges of building such applications. Then we're going to see louder. All right. Louder. Probably it's because maybe it would be better to have I don't know the other. Do you hear me? Do you hear me better now? At the end of the room? Is it okay? So? Let me try. Let me try with the... I'm sure it's better now. All right. So yeah, I was saying we are going to start by talking about the challenge of building distributed applications, and then to see a little bit what means doing that kind of application using Conductor and a Spring Boot application. We're going to see a live demo of Conductor in action and actually really see how to build that kind of application, and a little bit of news, and of course we are here also for some networking. I would be super happy if it is an interactive session, so as soon as you have questions, you can stop me and raise your hand anytime. So let's start by actually a little quiz and see if really you're building a distributed application today. Well, to answer that question, you have to see what is your application architecture. Is it based on microservices? Is it based on stateless functions? Is it based on containers that can be created and destroyed as needed? Can be also some services that can talk to each other using RPC, such as gRPC, for instance. Some asynchronous communication with an event bus, like Kafka. If you are in one of those kind of application, then yes, you are building distributed application. That's a good news. So what are the hurdles of running such applications today? First, and probably one of the most important, is that the network is unreliable. You cannot make sure that there will be no problem running your application based on multiple services that will be distributed on the network. The dependencies also can have failures. So how can you manage that in your application? Dependencies are never stable. You have new versions every day. And you need to make sure that any change doesn't impact too much your application, and your application still continue to work. One thing very important is, even if we have a lot of services that are deployed on the network, is how to manage the application state. Because at one point, your service is really loosely coupled and does exactly what it has to do. But when it comes to composition of multiple services, you need to manage an application state. So that's another hurdle that we have to take into consideration in building that kind of application. And also all the timeouts, retry, rate limits, because if you deploy as an API your service, you may offer that service to some clients, and you don't want those clients to go over what they are engaged to use. Maybe it's linked to a contract. But not only hurdles, we also have challenges in running those applications. How to recover when there is a failure, how to manage the application state, which is also a real challenge more than a hurdle. And all the transactions and rollback when the transactions cannot be completed because of one of the services implied in the transaction. Scaling distributed application means to be ready for large consumptions. We will see Conductor. How many of you heard about Conductor before today, actually? 5, 6, okay. It has been designed and implemented from day one because of this challenge, to be ready for a large consumption. It has been created at Netflix, and you can imagine for Netflix what it means to provide content to a wide audience on different devices. And we are talking about millions of users, right? And users. And the content itself is like super large compared to any other companies, probably. So building that kind of application means taking into account the scalability from day one. Scalability means managing pipes between services, like to make sure that we don't fall into some issues there. The backups and retries, all failures, retries, and rate limits are part of the scalability. The back pressure, we are really in kind of real plumbing here when the service is open from a tube to consumers, and the service is overconsumed. And services, of course, that can auto scale. Like, we cannot have a service without knowing from the beginning how much is going to be used. And opening this service, we need to make sure that it is dimensioned the right way. So let's talk about the use case now. And it can be seen as a very simple use case, a subscription application, where before the subscription it can have a trial period, and from the trial period send notification to the user that the subscription is going to start, do the monthly charge every month for the duration of the subscription, and having in parallel cancellation at any time, meaning during the trial period, or it can be also after a certain number of iterations of the monthly subscription. So this is really the logic of the application. And if you think about having services for every part of this application, really the orchestration between services becomes very important. Running services in parallels, really in parallels. Is it something that you have to implement in your application today? It's going to be very complicated if at the same time this parallelism needs to scale. Problems here can occur at any part of the workflow. It can be on the network itself. It can be a service is not available. If you rely on an external service, that external service can be also can have problems and can break your workflow. So in your application, you need to take care about everything here. In a traditional architecture, what can go wrong? If you think about, like, I have microservices, I put in place a pub/sub mechanism to share information between services. Connection will be with HTTP or gRPC. Each service knows the next one in the chain. Then we can have multiple problems. The version coupling. If I have a new version of my service, I need to make sure when I deploy it that the version of other service can follow as well. The deployment has to be done in a lockstep mode. It's like it's a full deployment, not just itemized deployment. The service are responsible to dispatch the calls to other service. So like we were talking before about the loosely coupling, we are not there. The routing based on the version of message payload, making sure that, when the payload changes, then the routing is broken. Message bus becomes a single point of failure, and the application logic is distributed across multiple services. So all those things can go wrong in a traditional architecture. Another thing that we need also to think about is the total cost of ownership of such application. The factor to increase the application TCO are mostly about the change management. By the way, according to all studies, 20% of the TCO is for the development. The 80% is really for the maintenance of the application. So the flow can change all the time because of business needed. The time to market, when the business says, I need an update on my service, on my flow, I need this to be implemented by tomorrow, or I did a new partnership with a partner. How long does it cost to implement this partner into the flow with their own service? This is critical to be competitive with your competition. Some changes is just redefining the flow itself without touching any services. And the documentation of the flow usually is actually inside the code. So this becomes very difficult when, after the development, the team moves, some developers goes to other teams or other projects, sorry, or even leave the company, and some new developers are joining the project. Usually, you know the nature of developers, right? They are it's a little bit half egocentricity and half opinionated. So they're going to say, you know what, it's going to be easier to redevelop everything. The support team needs also to understand the way everything is working to make sure that they can act on doing the debugging, all the debugging. The SREs needs to know how to scale up and down, and the management wants to make sure that they can give SLAs reports to their own customers. So, as a solution, we have service orchestration. And I'm going to present you Conductor, this open source project that has been built at Netflix and is maintained by Orkes. The founders of Orkes are the creator of Conductor when they were working at Netflix. After 6 years, they left, created Orkes to add more enterprise class services on top of the product, but making sure also that the product can be used in many different situations to many different industries as well, and comes to help implement some patterns on service orchestration. So Conductor has been made to scale to some extreme volumes, and it of course follows some design principles, like there is no single point of failure, all communication are persisted, distributed, prioritized in queues, all the orchestrator does the routing, not your application. So there is no need to implement anything about the orchestration anymore. The service can be either HTTP or gRPC. It's your choice. Services follow a single responsibility principle. So it's an event-driven architecture. And of course, Conductor is following all of the design principle. Takes care of the routing, takes care of the retries, the rate limits, the failure. Everything is handled by Conductor. So what means an application with Conductor? Actually, you need to remember 3 important things. First is the workflow itself. You're going to design the workflow. You're going to design how services are called between each other. You're going to design how they can be orchestrated according to some condition, or they can be iterated into loops. Workers is really what will mean a task inside the workflow. And those workers are stateless components and totally platform and language agnostic. They can run anywhere. They can run on the demo I'm going to do. They're going to run on my laptop. But the workflow itself is in the cloud. Can be developed in any languages. Conductor itself has been developed in Java, but the workers can be developed in either Java, Golang, Python, or C# or even JavaScript. And the application is the third component. The application really will use the Conductor APIs in order to start, stop workflows and trigger events to change the state of each workflow. As I said, it is open source. So if you go to GitHub /Netflix/Conductor, you're going to have access to all the source code of Conductor. You can implement in your own machine. You can implement in your own cloud infrastructure. I invite everyone to go and check. Of course, star the repo. As you can see, it becomes very famous. We have like 9.9K. We hope to reach 10K stars pretty soon, which gives you an indication about the community that is behind. Orkes provides a community support with a Slack channel where you can post your questions. And we are supported whatever you are using, our cloud infrastructure or your own and just open source. We are definitely supporting every developer, no difference. If you want to play before really going to the repo and fork or clone it, you can also use our playground. We have, if you go to play.orkes.io, you can just register and you have access to the entire platform to do some tests, even some development, and see what it means. I'm going to pause now and just doing a little quiz, and because of course, if there is a quiz, there is a reward. So I'm going to take one reward with me. I have this super cup with Orkes, And so the quiz is the following. On a standard cloud cluster, how many parallel tasks can one single workflow instance can execute? What is your guess? One? More? Give me numbers. More, much more. More than thousands. More than 64K. Less than 1 million. Actually, we don't know because the cloud crashed before the application reached the limits. Any final number? You're quite close. It was 300,000 parallel tasks in one workflow instance. So you won. For those who would like another one, there is another chance. So yeah, we are talking about scalability, right? So we need to put numbers behind that word. How many workflow instances a standard cluster can execute in 1 month? More than 9 million. Another guess? No, less than 1 billion. Actually, we could do billion, but it was a standard cluster. So same thing. According to the bench we did, we never went over 2 gigabytes of memory. Final number? We have 700 millions here. Okay. I need another number to do a comparison to see who will be the winner. So it was 500 millions. So you won. Thank you. So what means creating a Java application using Spring Boot and using Conductor at the same time? What does it mean? So my Spring Boot application here to implement my subscription application is going to be like this, divided really in 3 parts. One is the services. I need an email service to send notification. I need a workflow service to start the workflow and cancel the workflow. And I have POJOs. I have to do the monthly charge, start the subscription, cancel the subscription, update the subscription, and all the email metadata. And I have workers that I talked a little bit before, which is really the link between the task in the workflow and your Spring Boot application. That's it. So let's see Conductor in action, actually, with our Spring Boot application. I'm going to switch to, hold on, I'm going to go first here. I'm going to start by showing Conductor, just the UI, and then we're going to go into the code of the Spring Boot application. So when you arrive on Orkes Cloud or on your cloud, if you implement Conductor in your cloud, you can provision It's very easy to provision. You create a new cluster. You can say, it is my cloud, in my cloud infrastructure, or is it on the Orkes hosted cloud? And when you create, you just say, I want it on AWS, Azure, Google Cloud, which region, what are the cluster properties. So you give a name. You can give also which capacity you want. Is it a starter? Of course, I will have less capacity than a standard. And is it for test, development, pre-prod, prod? You define that, and then you have what is here with the version of your conductor. And then you can click on Conductor UI to go into the UI. From the UI, what you can see is all definitions of all workflows. So here I am in the playground. So if you register to the playground, this is exactly what you're going to see. And actually what we're going to see today as a subscription application, you can also go into it and see the way it has been done. You can copy and create your own subscription app if you want. Let me search for it. Monthly subscription workflow with trial. Here it is. So this is actually all the orchestration of all of my services that are in my Spring Boot application. So the workflow itself has some input parameters. I need a user ID, I need a user email, the billing amount, and the billing periods. And then, so the first thing we do is we set some variables that can be reused across the workflow. So no need to keep that in the state of your application. It can be just managed by your workflow here. And then we have a fork. And from the fork, we go here on the trial. So for the trial, we send an email to say, welcome, thank you for trying our product. And then we're going to wait for a certain duration. For the sake of the demo, the duration has been hard-coded at 10 seconds. After the trial period, we send the subscription to inform the user that the subscription is going to start. And then it's going to be charged every month. And here we have our loop to send the email of the charge itself and wait for the next bidding period. And the same thing, for the sake of the demo, we put like 1 month becomes 10 seconds. So we can set it quickly. In parallel, we have, and we implement it as a webhook to show also that we can support webhooks here. We have the cancellation of the monthly subscription, where we're going to send an email to say, okay, sorry, we took into account you want to cancel, and then we're going to terminate the workflow. Everything behind all of this is actually a code. It's a big JSON file. And if you don't like the UI and you prefer to just define your workflow by code, you can do it. You can also generate it from an external system. So based on whatever parameters you have, you can auto-generate the JSON that will be injected here as a new workflow, because the Conductor has also API, so you can send a new workflow that will be registered automatically here. Of course. We're going to use another microphone so everyone can hear it.
All right, so my question is there any kind of a loosely defined or strongly defined JSON schema that we could look at for editing this file manually?
Yeah.
Okay, so it exists. All right, great.
Yeah.
Can take care of the mic.
So the second part is, of course, my Spring Boot application. Let's make sure that it's connected here and works, because with let me stop and restart, because we never know with the when you change the Wi-Fi if the thing is working or not. So I'm going to go to the subscription application. It's, I mean, nothing else than a regular, very standard Spring Boot app. And from here, what we do is we have a bean that is an API client to Conductor. And from that, so some parameters are quite important here to make sure that there is a connection, authentication of the application with Conductor. Then we have the workflow services. The workflow services has everything to trigger the subscription workflow or to cancel the subscription workflow. And here, the only thing we do is instead of, in addition to log the info here, is to send an HTTP request to Conductor to say we want to cancel the subscription. I have all the POJOs here, and I have my Conductor workers. Conductor workers are actually very simple, I would say, dummy services here, that the only thing they do is they just describe which task correspond to that service, to that service with the relevant parameter. So here, for the send email, we have the email metadata POJO that's going to be injected automatically. So when the worker will be executed from the workflow, this will be automatically injected. I have the same for the monthly charge result. You see, it's very very small and very simple. And here I have all of my POJOs that gonna just do the work of the subscription request, the cancellation, the email metadata, monthly charge info result, the send email result, etc. And I have a controller, so my application can also offer to start and stop the subscription, which I can do because my application now is working by just sending a start subscription URL to call my application service. And I'm going to say I want a 3 months period, and the bidding amount is 100. I click on send. So here it says that success. I have a workflow ID. So if I go back here to see what are the executions, I can see there is a new one that is running right now. I can open it and see live that what is happening. So we are in the trial, and because we went over the 10 seconds, we already started the monthly subscription. If I refresh, I can see I am in the 3rd iteration here, so it's gonna stop soon. Let me refresh. Yeah. So now everything is stopped. We went to the termination and it's done. I can introspect everything, like the workflow input output that has been received. I can see the timeline when things have been executed. I can see the execution in parallel, the execution in sequence that have been made. So when there is a problem, it's very easy to introspect, to debug, because I have all the info that are necessary. I can run the same one. I'm going to go back to execution here. And I'm going to change. I'm going to say now I want 6. Let me clear this one. And I'm gonna start again the same subscription. So if I refresh, I can see I have my new monthly subscription that is running. So I am in the same situation. If I refresh, I can see I am in the second iteration, but let me go back to Postman and do a cancellation saying it's too expensive. So I click on send. Now the status is success. I did an update. I go back here, and if I refresh, I can see that this has been terminated. The loop has been terminated because we received the monthly subscription. So we went through that road. And we know everything about each task, the input, the output. We can see who was the user ID. The output, the reason was it was too expensive. So really information are part of the state of this execution. Any question? Yep. Here.
How is this different from something like AWS Lambda orchestration?
Well, we are agnostic of the cloud, of course. So even if, yes, you can use AWS and step functions, but what you can do is to have a workflow where part of it is in AWS and part of it is in another cloud. So you're not monocloud here. You're cloud agnostic. And of course, because we are pure player, we have much more features that are provided out of the box of Conductor than what you can see in AWS. It's also an open source project with a community behind. So it's a lot, differences are there, but it is to solve the same issue.
This room is a maze.
Thank you, Gene.
Yes.
Hi. I'm working on we have a mobile phone app,
Yep.
and we have a subscription.
Okay.
And one of our issues is if we don't give Apple, their 30%, and if we don't give Android their 15%, we're literally out of business. They tell us I'm going to use a bad word. No, they tell us to go away. And what you described seems really neat technically, but those issues. Our backend is REST, a Java server it's a Spring Boot server. Our backend is a Spring Boot. But our front end is an iPhone app and an Android app. And if we don't give them money, we're not in business.
What prevents you to put your iPhone and Android app to call that backend? This is the best back for front, right?
But we have to pay them. We have to subscribe with them.
Because they're providing that as a service, right?
If we don't pay them money, if we don't tell them we're subscribing to them,
Yeah.
We're out of business.
But that can be part of the subscription.
Okay. And
It's just one of the service.
Are you making that easy for me to subscribe to Android and Apple?
Well, how Android and Apple are providing this subscription service to you as a API, as a
I'm using we're paying 0.1% to another company to help us with that.
all right. So maybe we should talk to that company. But definitely, let me go back to the definition here. If I need to add another task that is not something in my Spring Boot application, that is something provided by Google or Apple, and I can have, based on the user device, I can detect it, and then I can switch as a fork like we have here, which service to call. And adding a new task in my workflow is just something trivial. Here I say, is it an event that I'm going to receive? Is it something that I want to call specifically? Is it something that I want to code by myself? All options are there, as you can see. If it is something very trivial code, you can do an inline task. If this is something that is running as an API, I can do an HTTP call. So I can say it's an HTTP task, and the parameters would be what is the URL of the service that you want to call. So this is totally possible. This is totally independent from your front-end application. You're going to rely on something like that, but today you are using those two services, and you have to pay them, of course, because they are managing the subscription for you. But it's going to be an event that comes to you. And that event can be part of your own subscription workflow. I would be very happy to help you on that, to brainstorm on the thing. Yeah.
I'm curious what you see as the like idealized architecture for this, right? Is it basically, if you look at a sequence of code that you have that just executes a chain of RPCs, is it just like replace every RPC with, I guess it's a workflow, or I'm not sure, it's not a workflow, but a task maybe, or something like that? That's just kind of the idea, is to kind of replace that. Is there an easier way to effectively generate that mapping from something as a little bit more like semantic, just like looking at your code and kind of inferring what the actual graph is?
That cinematic actually is as I showed before, is actually a code. So yeah, generating that code can be something that that can be implemented as well. But there is something even more interesting that is coming, and we are working hardly on that, which is using AI and the concept of Copilot. So in one of the next future version of Orkes, you're going to have a Copilot in the designer, and you're going to say, I would like an orchestration with this service to do that kind of thing, and automatically it's going to draw the orchestration for you. But you can, of course, change on the after the generation.
Can you talk a little bit? Can you talk a little bit about the operational features that you may have in this sort of like service discovery, or managing how many of these servers? Well, actually, they'd be orchestration services, part of the application. That kind of infrastructure around the operational piece.
Yeah, unfortunately, I cannot show it to you right now, but we have a way to see exactly everything. Let me just go back to my own instance here. And I don't have it, but we have metrics and alerts that will give you an idea. So we are providing everything that is executed on, behind the scenes are sent to Grafana, and you have like absolutely all the metrics of everything that is going behind the scenes. So you can see what is going there. As you can see here, the total number of tasks being completed per seconds. So you can know, it's very important to know how long a task has been took to be executed, because for example, in one workflow, you can have a workflow that lasts for 2 hours, but just because of one task. So if you know it, you can introspect that specific task and understand why it took so long, and improve it there's going to be the entire workflow and then the entire application that can benefit from that. So it's very important to have the metrics. That is the first thing. The second thing is, because we are providing the cloud infrastructure as well, we are, of course, taking care of all the retry and rate limits, etc. for you. So you can define all of those metrics also, rates limits. You have, on each workflow, on each task, you have a lot of parameters that you can set to say, I want a timeout, I don't want this task to be executed anymore if it goes more than, I don't know, like 2 minutes. I want a retry, but I want to retry only 3 times, not more. It means that there is a bigger problem that anyway, it doesn't mean anything to retry like hundreds times if the service won't be available after a couple of hours. So you can be, if there is an error, you can be notified. So really all the features that that you need when you run that kind of infrastructure. So you can really pilot the orchestrations that are running behind the scenes.
How about something like service discovery? Right? Is that offloaded to third-party?
Yes, service discovery is more something that should be a third party. Here we are more in the orchestration of the services.
Thanks.
You mentioned the usage of persistent queues. Where are they in this workflow?
So behind the scenes, the persistence of the orchestration itself is stored in a database that we are using. It can be something that if you install in your own infrastructure, you decide on which database that you want to put that, but it can be a PostgreSQL.
And how do you upgrade your workflow? Because you said versioning and all that stuff.
So every time you're making a modification, you have the option to define a new version. Like if I go back to the definition, sorry, it was not this one. When I am here, let me go back there. So I make a modification and I say, when I save, I can say that's a new version, and I increment the version number. Yeah.
So you store events, right? So can I replay them later on? Let's say I want to replay events from yesterday.
Yes, you can.
My workflow, fix code, improve code, see how it works after I change things.
Yes, you can do that, of course.
Yeah, so do you have any database to store the metadata for the workflow? Like how the workflow define, and then what the state of each of the execution, do you store in any kind of database?
Yeah, we are storing in the internal database. Everything, all the state, the workflow. Again, the workflow, what is stored is this. As you can see, all the parameters are there. And you can either use the UI here, or you can change the code here. And we do auto check every time you do a change. And everything is stored in the internal database.
Hi. Sorry if I have missed this. Could you explain one more time how you can integrate your application with Conductor?
Sure.
How can you use Conductor as an orchestration?
Sure. They are working. The application and the orchestration are really working on the side, and the communication is made by using an SDK from your application, and your application is listening to by doing the polling to the workflow to see if there is a workflow instance running, if there is a task that is linked to one of the service that is defined in your application. The execution of a task takes around like 20 to 30 milliseconds. And this is something we are improving over time, and we will be soon something like lower than 10 milliseconds. So it doesn't really bring an overhead. There is an overhead, of course, but with all the features that are behind, it's not really significant. Yeah.
Is there a way to handle different error codes?
To
handle different error codes, or do you have just a state of failure and that's it?
No. There is because it can be technical failures or it can be logical failures, like the cancel subscription. As you can see, the loop has been canceled, but if I look at the execution here, it stays as completed, which is normal. There was a kind of error, but it was a logical error, an application error. As a technical error, I can see here we have like something failed, and I can see if I introspect which service, which task was implied in this failure, or it can be there was a timeout, so it auto-terminated. Let's go to see this one. So it's this task. I can go and check this task failed. I can go and see the log. I don't have a log available on this one, sorry, but I can really introspect what was, I don't know really what was that. Yeah, fail in the payment.
But what if I want to define, like for the same step, several custom error codes that it can return, not just failure, but specific error reasons, and depending on the reason, go to different steps?
That would be a logical error that you can define. It's going to be an output of your task. And from that output, the next part will be a conditional fork that can be based on the value of that variable. So based on the error you have, you can go to one way or you can go to another way.
And then I can mark the state of the whole workflow as failed.
Yes, absolutely. You can do that too. So you can go first through some other task in order to send some notifications, logical notifications or things like that, and then to terminate the workflow as an error.
And retries would be done with the loop?
Yes.
As you...
For debugging, it's really interesting because you can go back to something that failed and say, I want to rerun in the same condition. So you're going to see exactly what happened live. And you don't need for that to restart your application. You can just restart the workflow.
Looks like we're out of questions.
Super, thank you so much.
Do you want me to do random numbers? Do you want me to do random numbers?
Yeah.
Prizes?
We have the spinners.com.
Feel free.
Frank, you want to conclude a little bit?
Thank you, Olivier. Before we leave, we have 6 IntelliJ license. I was just corrected a few seconds ago instead of 3. And courtesy of Cockroach Labs, we have Cockroach DB, the definitive guide to raffle off. So, Jean, if you want to.
All right. I know there's all sorts of complicated ways of doing this with websites and random wheels and putting your names in things, but we're going to do it the simplest way. We're going to count off. When I point to you, say a number in order. And then I'm going to draw the random numbers electronically, and we'll do prizes. So let's count off. Black hat? You skipped a number. 12, 13. Okay. They skipped a number, but it's fine. Rick? Back row? Guy on phone, 23? Yeah, 23, 24. Okay. Whoever's in the back corner is 27, 28. All right, random number time. Number from 0 to 28. We have number 20. Who is number 20? These aren't very random today. 11. All right, that was 4 numbers, right? Okay. 13? 9. All right, congratulations to all of our winners.
Thank you. So the winners, just send info@javasig.com and we'll send you a license. So have a good rest of the summer. We'll see you in September. Thank you.